Hey everybody, how you doing today? Hopefully you're having yourselves a great Monday and you're watching this on Monday night. If you're watching this on Tuesday in class, come on guys, I asked you to do one thing, just to watch this one 10 to 15 minute video. Not too big of a thing to ask. But hopefully you're just watching this on Monday night and you're having yourself a great Monday night. Today we're going to be graphing sine and cosine, focusing in on just doing translations. And a friendly reminder, a single period of sine looks like this, a single period of cosine looks like this. There are 5 points of importance for each whenever the graph is at a maximum, at a minimum, or at an x-intercept, or just or an axis point. So I'm going to do a couple problems. They're both going to have vertical and horizontal translations. I'm going to do one in sine, one in cosine, one in degrees, one in radians, and this one appears to be the sine problem being done in degrees. Let's go. These work the exact same way that you're used to problems working with translations. This is inside the function and it says minus 30 degrees. You do the opposite, that means it's going right 30 degrees. If you were to plug 30 degrees into that equation, positive 30 degrees, that would be 0. That's why it's right 30. Plus 5 on the end, that affects the y-coordinate, which means it's going up 5. All right. Because it's going right 30, in the middle, like when I think about my parent graph, oh, by the way, I have to graph 2 periods. This is only 1 period of sine, so I'm basically going to have to do this twice. Once for over here for the positive, and then once in the negative direction. If you think about the worksheet that we did, that was graphing 2 periods of sine and cosine. So this 30 degrees is kind of my starting point. So I'm going to put 30 degrees right here in the middle. And if I go forward 1 full period, an extra 360 degrees, that would put me at 390 degrees. And if I went 360 in the other direction, that would put me at negative 330 degrees. And you need a total, if you're doing 2 periods, you need a total of 9 points of importance. So you gotta go midpoints and then midpoints of the midpoints. Halfway between 30 and 390. 30 plus 390 is 420. 420 divided by 2 is 210. 210 degrees. Over here, halfway in between negative 330 and 300, add them up. They add up to negative 300. Divide by 2, negative 150 degrees. And I do the midpoints of all of these. Let's see, these two add up to negative 480, so if you divide that by 2, you get negative 240. These two add up to negative 120, divide by 2, and you get negative 60. Add them up, divide by 2, 240 divided by 2 is 120. Add them up, divide by 2, they add up to 600, which means 300. And because of all of that, these should all be the same distance apart. Negative 330 to negative 240, that's 90 degrees. If I add 90 degrees, I get negative 150. If I add 90 degrees, I get negative 60. Add 90, you get 30. Add 90, 120. Add 90, you get 210. Add 90, you get 300. Add 90, you get 390. You essentially, what you could do there is you could do the period divided by 4, because you're breaking it up into 4 zones, which tells you that each of these benchmarks should be 90 apart. Your y-axis. Technically, the y-axis should go where it should be, at 0. And if this is 30 and this is negative 60, 0 is approximately there. So I'm going to put my y-axis there. But if you want to put your y-axis on your middle point, your x-axis, or your y-axis straight through your middle point, I'm okay with that too. Anyway, if it's going up 5, that means that my axis is now going to be at 5, and because of the amplitude of 1, it's going to go up to 6 and down to 4. I didn't really start at 0, so I put in this little thing to say I didn't start at 0. And there's an axis, and you must draw in the axis, dotted line. Okay, now, I've completely set the problem up. I now need to put my sine dots into there. I'll always say, like, each period starts somewhere and ends somewhere. So period start point, period end point, maximums, minimums, middle point. All right, so at 30 degrees, that was my start point, and at the start point, I am on the axis. So here. Now, a period always begins and ends at the same spot, which means that way out here at 360, it's also 0, and way over here at negative 330, it's not 0, it's on the axis. Other axis points, that middle point at pi, so halfway through the period. So that would be here at 210 degrees is on the axis, and negative 150 degrees is also on the axis. Then after that, it does this whole up-down thing. So first it goes up to 6, then it goes down, and in the other direction you just repeat. It was going up here, which means here it's going down, which means the next time over here it's going up. And you should have yourself a nice looking graph at that point. And connect the dots. La 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 la. Connect the dots. La 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 la. Boom! 2 periods of sine. And if you compare this to the sine worksheet that you worked on, the graphs should look absolutely identical. The only thing that changes is the numbers on the x-axis and the y-axis. All right, number 2. All right, cosine problem, and this one is in radians. Because of minus pi over 4, that means it's traveling to the right, a distance of pi over 4. If you plug pi over 4 into here, you get 0. Positive pi over 4. That tells you it's going right 4. A minus 6 on the end, down 6. And I make my x-axis, and right in the middle of my x-axis is going to be my start point, which for cosines typically 0, but because of the horizontal shift, the translation, my start point's pi over 4. All right, you might want some side work because you're going to have to do fraction midpoint stuff. Do a side work here. So pi over 4, the period is 2 pi, so I'm going to add 8 pi over 4. That will give me 9 pi over 4. If I subtract 8 pi over 4, that would be negative 7 pi over 4. Okay, midpoints. Halfway between 1 and 9 is 5. So this one would be 5 pi over 4. Over in this way, halfway between negative 7 and positive 1, negative 7 plus 1 is negative 6. Divided by 2 is negative 3. So negative 3 pi's over 4. And then midpoints of all of those. What's halfway between 5 and 9? 7. So 7 pi over 4. What's halfway between 1 and 5? 3. So 3 pi over 4. Halfway between pi over 4 and negative 3 pi over 4? Let's see, these two add up to negative 2 pi over 4, which is negative pi over, so negative pi over 4. And then halfway between negative 3 and negative 7, negative 5, so negative 5 pi over 4. And 0 would pop up halfway between pi over 4 and negative pi over 4. So that is where I put my axis in. And I'm going to demonstrate here that I'm not starting at 0. And it's going down 6, so negative 6. And it's an amplitude of 1, which means it stretches up to negative 5 and down to negative 7. And put an axis through your y equals -6. All right, here we go. Now we are going to put this parent function, 2 periods of this parent function, into here. And we started again at pi over 4. And at pi over 4, at the start of a cycle of cosine or a period of cosine, it is up the top, up at 1. So here, my top value is -5. So at pi over 4, my value is -5. Now, every period of cosine starts and ends at the high point. So if it's at a high point at pi over 4, it's also at a high point of 9 pi over 4. And -7 pi over 4. What about their midpoints? The midpoint of the high points, it's a low point. So at 5 pi over 4, I put in the low point. At -3 pi over 4, I put in a low point. And then I have 2 more points. I've put in my high points, I've put in my low points, and in the middle would be zeros. So halfway between here and here, at 3 pi over 4, I'll have not a 0, it's on the axis. At 7 pi over 4, it's on the axis. -pi over 4, it's on the axis. -5 pi over 4, it's on the axis. You've got some nice looking graphs here, and now you make yourself a beautiful cosine graph. Don't make it pointy, make it nice and roundy. Connect the dots, la 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 la. Connect the dots, la 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 la. Connect the dots. Alright, and that's a cosine graph going right pi over 4 and down 6. What's the one thing I want to stress here on my last thought? I don't remember. Alright, so that's graphing sine and cosine with just translations. I'm going to have some practice for you to work on, graphing translations. If you'd like to look at that worksheet, here it is right here. So we're going to be graphing these 18 functions. It doesn't mention graphing 2 periods. Make sure you graph 2 periods, because when you graph when you get to your answer, the answer key, check it out, it's always 2 periods. Ooh. Anyway, have yourselves a great day, everybody. And I will, let's practice these, graphing 2 periods of each. And tomorrow, 24 hours from now, I'll make a video doing dilations, which is going to change the amplitude, and then also changing the horizontal shift, giving it a period. And those problems will be awesome. Have a great day, and I'll talk to you soon. Bye-bye.